Hi everyone, it's Coach Brett here, and today I'm going to be going over for Algebra 2 students properties of rational exponents and radicals. So we've been working with radicals of differing degrees, different indexes, such as like the cubed root of 27. So we called that number the index. And now we have to kind of look at this in a different way with something called a rational exponent. When I think of a rational exponent, it's easy for me to understand it as a fractional exponent, So let's kind of examine what a fractional exponent means, and then we'll put it to use, okay? All right, so b to the 1/2 power really means the square root of b. B to the 1/3 power means the cubed root of b. B to the 1/5 power means the 5th root of b. So these actually mean the same thing. It's a different way to write it. Now remember, we have all these different equivalent forms of the same linear functions, quadratic functions. Now we have another way that we can write radicals. We can write them with fractional exponents. I'm hoping you notice that the index is the bottom of the fraction. The index is the bottom of the fraction. So I'd like you to take a pause here and try and define what you think b to the 3/2 might mean, okay? Press pause, try it. Take a guess if you have to. All right, you're back. So b to the 3/2 actually means the square root of b cubed or the square root of b quantity cubed. Those two things mean the same thing, and we're going to use them in different ways. All right, and that's basically what happens. The definition of a base raised to a fractional exponent, the bottom of that fraction becomes your index, and b would be raised to the numerator of the fraction, or the q root of b to the p, okay? All right. Now, I take those rational exponents, a to the m over n, so that would be the nth root of a to the m power, again, or the nth root of a to the m. And now I'm going to add a negative exponent to that, okay? So a negative m over n. Okay, so as a reminder, negative exponents do not make a number negative. They basically make either a fraction or they bring whatever's in the denominator up into the numerator. For example, if I gave you a to the -1 power, that would mean 1 over a. Whereas if I gave you 1 all over x to the -2 power, that would mean x squared. So you either bring it up and make it positive, or you bring it down and make it positive. All right, so a to the -m would be 1 all over the nth root of a to the m, okay? All right, let's rewrite. I want you to try now. Try rewriting as using exponents and rewriting using radicals. Okay, so the square root of 9 cubed would become 9 to the 3/2. The index becomes the new denominator. Remember, when there's no index, it is assumed to be a 2. All right, rewriting 16 to the 5/3. That would be the cubed root of 16 to the 5th, or the cubed root of 16 to the 5th. Okay, now why is it that I'm writing it both ways? Well, you're going to see that I find when I have to evaluate expressions that involve fractional exponents, considering it like this makes it easier to simplify. So when the base is a number, I tend to write it like this because it'll be easier for me to simplify. But if the base is a variable, then I tend to write it like this. Okay, so you're going to have to kind of get used to it. So we'll practice it and see what happens, okay? All right, so here we've got a to the 3/2. It says evaluate and simplify, okay? So the first thing I'm going to do is I'm going to write it as, oops, sorry, get my eraser there. I'm going to write that as the square root of 9 cubed. See, it's a number. So now if I do that, the square root of 9 is 3. So 3 cubed gives me 27. But if I had written it like this, it might not have been so clear what you had. Okay, that's why it's sometimes easier to use this. All right, 16 to the 5 halves means the square root of 16 to the 5th power. The square root of 16 is 4. 4 to the 5 power. 4 to the 3 is 64. So 64 times 4 is 256. All right, try this next one. 32nd raised to the 2/5 power. Try it. Pause and come back. All right, so we would have written that as the 5th root of 32 squared. Well, the 5th root of 32 is 2, so 2 squared gives me 4. All right, here we've got a negative. This is a negative 2/3. 64 to the negative 2/3. Okay, first I'm going to rewrite it as 1 over 64 to the positive 2/3. Then I'm going to evaluate the cubed root of 64 squared. Well, the cubed root of 64 is 4. 4 squared is 16, so this would become 1 over 16. Here's another negative exponent, 16 to the negative 3/4. Again, I'm going to make it positive first by rewriting it. That's just me. Like it positive. Then I'm going to take the 4th root of 16 cubed. All right, the 4th root of 16 is 2, because 2 to the 4 is 16. 2 cubed is 8, so my answer here would be 1/8. All right, last thing I want you to remember when you are dealing with exponents is that if you are multiplying exponents that have the same base, one of the properties of exponents applies. Power times the power, we add those exponents. So this would become 7 to the 1/2 plus 1/2, which would be 7 to the 1, which is 7. Okay? All right, guys, so this is my first video on roots and radicals and just dealing with turning fractional exponents into radicals or vice versa so that you can evaluate them. I hope that was helpful and have a great day.